Hello, my name is Tiara Kusuma Dewi, and today I will share to you my final report of Senior Mechanical Laboratory courses, which is about the steam engine experiment. During the semester, I have been supervised by Pak Jatiwibowo Jamari, and just for the overview, the steam engine experiment will discuss about the basic concept of three different courses, which are fluid mechanics, heat transfer, and thermodynamics. In this video, we will discuss about 5 main topics that consist of experiments preparation, assembly, experiment, analysis, and last but not the least, conclusion and feedback. Start from the preparation of the experiment. We have done three different preparations. The first one is proposing the experiment's design. First of all, we need to propose the rough plan and followed by the detailed one. Second, the shipping planning. In this section, we choose the best scenario for the shipping plan and then estimating the shipping cost and comparing with the real one. And third, we talk about the component purchasing. For the detailed discussions, we will discuss it for the next few slides. Experiments design. For the rough plan, we have planned to make a steam engine that consists of boiler and also turbine. First of all, we need to transform water into steam by using a fire. We boil the water. After we produce the steam will flow into the propeller and blow it until the propeller starts to rotate. After it rotates, it will turn on the motor and then the motor will turn the steam into electricity and this electricity will turn on the LED. That's all about the rough plan. Moving on to the detailed one, we divided the steam engine into two different schematics, which are the horizontal and vertical. Instead of LED, we replace it using the voltmeter so that we can get a specific value of the voltage that is produced by the motor. And for the variable that we take during the experiment, we take two different variables. The first one is the voltage and the second one is temperature. We take this variable every 30 seconds in 8 minutes of experiment. Second is the shipping plan. We plan to ship the components twice. The first one is from Jakarta Selatan Pancoran to Bandar Lampung Teluk Bentung Barat, and then from Lampung we ship again to Riau Dumai. For the estimation price is represented by the red color. This estimation price for the 5 kilogram weight of components. However, we have less weight of the components so that the real shipping cost is much cheaper than what we have been estimated. To make the steam engine experiments that we have been designed, we need this kind of components that is listed in this table. And for the total price for all components is about 700,000 rupiah. And this component we can obtain from the online purchasing and also the offline purchasing. Moving on to the assembly part, to to make the steam engines experiment, we need to prepare some components first. The first one is the boiler. For the boiler, we using the electrical mug, and then we do some modification to the electrical mug so that it can turn to be the proper boiler. The modification that we made is to make two holes at the closer part. The first hole for the entering the water to the boilers and the second hole for the steam get out from the boiler. And the closer part and the main body is stick together using the sealant glue so that the boiler that we make can be as vacuum as possible. Uh, Moving on to the thermometer, the second component is the thermometer that stick to the T pipe. We using the sealant glue as well to make the system as vacuum as possible, and then we using a white pipe that has a smaller diameter compared to the gray one as the connector. the same thing goes to the pressure gauge. The first plan is we using the pressure gauge to measure the pressure that produced by the steam. However, the pressure is not that much so that the pressure gauge cannot recognize it. So that we um, replace the pressure gauge using the membrane. Actually, it is the elastic glove so that we can know whether the pressure is moving through this pipe or not. The last but not the least for is the turbine. In this case, we using the water pumps, but instead of inserting the electricity, we inserting the pressure to produce the electricity, and we using some adapter pipe to the turbine so that it can connect all these components to make one complete steam engine. Now we are in the experiment part. For the experiments, besides using the component that we have assembled before, we also need some additional components. For the main components, we need to add the voltmeter. And for the supporting components, there are some things that we need to prepare also. The first one is the white pipe uh, that acts as the connector, the adapter pipe, the 90-degree elbow pipe, and also the T pipe. Besides, we also need some glue. The first one is the gun glue and also the sealant glue. The sealant is used to substitute or is need to cover some part in the systems so that there's no leaking occur in the system. Talking about the working principle of the steam engine, the first one is that the water that contained in the boiler is being heated, and then the water transformed to the steam. And then the steam will flow into the pump that consists of propeller and the motor. And then the steam is converted into the electricity. On the way steam goes into the pump, the temperature and the pressure will be measured. And this experiment will be done twice. The first experiment is for the schematic one, which is the horizontal, and the second experiment is for the vertical. During this experiment, we do change some variables. In this case, is the length of the pipe and its positions, uh, in the hope that we can analyze some basic theory of these three different courses. The first one is the thermodynamics. We will talk about its workout, which is the work that produced by the pump. The second course is the heat transfer. We will talk about the convection heat transfer. And the third one is the fluid mechanics. We will talk about the Bernoulli equations. And the variable that is measured is the voltage and also the temperature every 30 seconds in 8 minutes of experiment. So now we're going to the analysis part. The first courses that we want to analyze is the thermodynamics. We are focusing on the turbine in the steam engines experiments. The work that produced by the turbine is called as the workout. The workout can be calculated using the formula of the rate of the work produced, W dot, minus the mass flow rate of the fluid, which represented by the m dot, is equal to enthalpy into the system minus the enthalpy that out of the system. In this experiment, we assume that the temperature out of the system is equal to the room temperature, which is 27 degrees Celsius, and the mass flow rate of the system is assumed to be 1.5 kilogram per second. The value of the enthalpy is obtained from the steam table, which is table A2. This is the sample calculations. In this case, we take the experiment value when the temperature that into the turbine is equal to 100 degrees Celsius, and we get this value of enthalpy in, and then the out, as we assumed before, 27 degrees Celsius, and we get the enthalpy out of the system, and the mass flow rate, which is 1.5, And then we can calculate the work produced by using this formula. And then we get the work produced, which is 188.7 kilowatt. From the previous sample calculation, we know that since the enthalpy out of the systems and the mass flow rate of the fluid has been assumed, we know that the work produced depends on the enthalpy that entering the turbine. And the enthalpy is increasing along with the increasing of the temperature as shown in the table A2. We know that the increasing of temperature will cause the increasing in enthalpy also. And then we know that the work, which is the power, is proportional to the voltage produced by the turbines. In conclusion, the increasing in temperature will cause the increasing voltage produced by the system. The conclusion that we have been made in the previous slide has been proved using this experimental result. This is the verticals and this is the vertical schematic experiments. Since the vertical and horizontal schematic give a similar experiment result, we only use the experimental of the vertical schematic to show or to prove the conclusion that we have made before. We can see that the increasing in temperature, the orange line, will cause increasing in the voltage produced by the turbine also. However, there is some part which is the last minute of the experiment that show decreasing of the voltage while the temperature is constant. In this case, while the temperature is constant, the voltage produced is decreasing. It might be happen because the steam that produced by the turbine, the steam that produced by the boiler is decreasing because some of the water has turned into the steam that flow out of the system. Now we are moving on to the heat transfer analysis. Since we are focusing to finding the convection coefficients, we need only focus on the boiler since the boiler in horizontal and vertical are the same. So the schematics can represent both of those schematics. From the schematic, we know that the Q in is equal to the A storage, and this W dot can be cancelled out. And this time represent how much time taken to reach 100 degrees Celsius in horizontal and also in vertical. Using this formula, which is the convection heat transfer and the energy storage, we can find the convection coefficient. And from these sample calculations and also using these assumptions, we know that the difference of the convection coefficient is appear, and it might be caused by several reasons. There are first, the value taken 30 seconds in experiment is a big gap to know the exact time when it reached 100 degrees Celsius. Second, the amount of the water cannot be exactly the same between those two schematics so that we can get the different convection coefficient where it should be the same. Now we moving on to the fluid mechanics analysis. The left side of this slide is showing you the schematic of the horizontal, while the right side is showing you the vertical schematic. Using this assumption, this assumption is applied for both schematic. The difference of both of them is head, the different head between the pressure one, which is the boiler, and the position of the pressure or the membrane that is represented by the rubber glove. We know that the pressure that produced by the horizontal and vertical are both positive, and the pressure that produced by the horizontal schematics is bigger than the vertical one. Just to make everything clear, I will repeat what I have said in the previous slide. From the sample calculation, we can see that the pressure produced by both schematics is positive. It can be seen by observing the rubber glove that pop out of the system during the experiment. This is the pop out side of the horizontal, and this is the pop out side of the vertical schematics. Besides, the sample calculation also show that the pressure produced by the horizontal schematic is higher than the vertical one. It can be happen because the pressure will decrease along with the increasing in elevation. Then the elevation in vertical is higher than the horizontal. We can see that the pressure in horizontal is higher. We can see that the membrane is slightly bigger in the horizontal schematic. You can see that the pressure is up to this part when the vertical only focus on this part. In conclusion, there are some basic theory from those three different courses: thermodynamics, heat transfer, and also fluid mechanics that can be improved using the steam engine experiments, although there are some human error there, and also the tool error. Besides, during these courses, we have learned many things. During the experiments, we have the hands-on experience. We have learned about computing and analyzing the data and applying the concept that we have learned in the class, and also presenting the experiments in the verbal. For example, through this video. And during this class, we have learned about planning and experiments, solving the problems, be active in discussion, and also be updating. For the feedback, I personally like this kind of teaching method when the lecture gives the opportunity to the student to do what they want. And this method of teaching is focusing on the self-development of the student themselves. However, compared to the material that we supposed to get during the offline class, there are much knowledge that we miss. For example, we do experiments using the refrigerator machine, or the air conditioner machine, or wind tunnel, Rankine cycle, or even the turbojet engines. I think it will be better if we keep following the module while take this experiment as the semester project. Um, Maybe that's all for me. Thank you for enjoying this video, and bye bye.